Give me a formula for the entropy of the universe as a function of time. Here's a script for a YouTube video as if spoken by Richard Feynman himself. Meta. AI does not clone real people, but there are thousands of fake Feynman videos out there. Got it. Here's the same Feynman-style script with director's notes baked in. Use these for pacing, emphasis, and body language if you or a voice actor are recording it. Title: The Universe's Entropy, or Why the Future is a Bunch of Empty Space. Duration target: approximately 2:30 style. Feynman lecture, Caltech, 1960s. Stool, chalkboard, sleeves rolled up. 00. Open on Feynman sitting on a stool, legs crossed, chalk in one hand, gesturing loosely. The entropy plot is already on the board behind him. He looks straight at camera. Feynman. Casual, amused tone. Beat. All right, so? Short pause, slight grin. You want to know about the entropy of the universe. Holds up both hands, framing the whole thing. The whole thing. As a function of time. 008. Stands, taps chalk on the flat early part of the curve. Looks puzzled, like the question itself is funny. First off, what does that even mean? Entropy, you remember, is just a way of counting. Turns, points chalk at camera. How many ways can you rearrange the insides without me noticing? The more ways, the higher the entropy. Nature likes high entropy. That's the second law. Waves hand dismissively. It's not a law like don't steal. It's more like leans in. Things get messy unless you work at it. Shrugs. Gestures to axes. Draws log scale ticks fast, sloppy, like he can't be bothered to be neat. So let's draw it. Time on the bottom. And we're going to cheat and use a log scale because the universe is old and it's going to get way older. Entropy on the side, also log scale because the numbers are whistles low, ridiculous. Chuckles, 040. Taps the flat line from 10 to the power of minus 10 seconds to 380,000 years. Tone becomes more curious. See this flat bit here? This is the early universe. Hot soup, photons, neutrinos, a little bit of hydrogen and helium. And the funny thing is, the entropy here, pauses, eyebrows up, it's constant. Not exactly 0, but it's not growing much. 0.54. Mime stretching a balloon slowly. Why? Because the universe is expanding, sure, but it's expanding adiabatically, like a gas in a balloon that you pull out, slow hand motion, slowly. No heat in or out. The photons just get redshifted, stretched out, cooled down. But the number of ways to arrange them per volume, taps board, that stays about the same. 108, turns back to camera, counts on fingers. We know this number, we measured it. Kobe, WMAP, Planck. They took the temperature of the sky, 2.725 Kelvin, and you count the photons. You get about 10 to the 88th power dollars, maybe 10 to the 89th power times Boltzmann's constant. Writes 10 to the 89th power K sub B and underlines it twice. That's the entropy of the cosmic microwave background. The neutrinos add another 70% or so. That's it. Dust's hands. That's the whole universe entropy-wise for the first 380,000 years. 132. Draws the rising slope. Voice gets more energetic. This is the part he likes. Now. Beat. Grins. Then what happens? Gravity. Slams chalk down for emphasis. Gravity is the great anti-thermodynamics guy. It clumps things. And when you clump things, you make black holes. 144. Holds up a finger, mock serious. Now a black hole, you know, I never liked him at first. But Bekenstein and Hawking figured it out. A black hole has entropy, huge entropy, proportional to the area of the horizon draws a circle, not the volume. Take the sun, collapse it to a black hole, and its entropy jumps by a factor of 10 to the 20 power. Eyes wide. You make one lousy black hole and you've already beaten all the photons that ever existed. 2 o'clock. Sweeps arm across the board to indicate all galaxies. So you look out at the sky. Every galaxy's got one of these monsters in the middle. M87, Sagittarius A underscore. We weigh 'em. We watch stars orbit 'em. We even took a picture of one. And when you add up all the supermassive black holes, you get underscore writes 10 to the 103K underscore B big underscore about 10 to the 103. 215 taps the red today line. Tone drops more reflective. That's where we are today. 13.8 billion years. This little red line here. The photons are still there, but who cares? The black holes are running the entropy budget. Chuckles. 225. Points to far right of plot. Voice slows down, gets quieter. So what's the end game? Here's the crazy part. Hawking told us black holes aren't really black. They evaporate. Slowly. A solar mass black hole takes 10 to the 67th power years. The big ones take 10 to the 100th power years. But they do go. 240 spreads hands wide. And when they go, all that entropy they were hiding, it comes back out as boring, low-energy photons. Heat. Static. If the dark energy we see is a cosmological constant, and the data sure looks that way, then the universe ends as de Sitter space. Just empty space with a horizon. And that horizon has an entropy. You calculate it, and it's about 10 to the power of 120. 258 puts chalk down, leans on stool, looks right at camera. Beat. That's it. That's the maximum. The universe can't get messier than that. It's just underscore underscore done. No more stars, no more black holes, no more you and me to talk about it. Just a thin gruel of photons at 10 to the power of minus 30 Kelvin, softly. 312. Picks up chalk again, spins it, grins. The wonder comes back. So the story of the universe's entropy is simple. It started pretty organized, got clumpy because of gravity. Black holes hoarded all the entropy for a while and then they gave it back. The second law wins. Points at camera. It always does. 325. Tone shifts. Genuinely puzzled, excited. The amazing thing isn't that the entropy goes up. The amazing thing is that it started so low. Why was the early universe so smooth? Why didn't it just start as one giant black hole? Shrugs, throws hands up. I don't know. Nobody knows. But that's the fun part, right? If we knew everything, we'd stop looking. And the universe is way too interesting to stop looking. 340. Stan starts a racing board casually. All right, that's all for today. Go home, think about it, and don't forget. Points chalk at camera, winks. Nature isn't trying to trick you. She's just got a bigger imagination than we do. 348. Cut 2. Coco the Bulldog on the couch. Another wild weekend caption. Hold 2 seconds, fade out. Director notes summary. Pacing. Fast when explaining, slow down on the big conceptual beats. It's constant. Black holes. 10 to the power of 120. I don't know. Feynmanisms. Say you see, or the darn thing if it feels unnatural. He'd trail off, restart sentences. Sounds. Chalk taps, eraser squeaks, small chuckles. No laugh track. It's a lecture hall. Expressions. Eyebrows do half the work. Puzzled, too excited, too awestruck, too amused. Want me to time code this for a 60-second short version too?